Good morning, grade 8s. Hope you are well. Today we are finally starting with maths for term 2. I hope you are excited about this. So we're starting with patterns. Patterns is something you started with in grade 7. So most of today's work is about the revision of grade 7. Nothing today should be new to you. Maybe the method. I prefer this method. It makes it simpler. So just bear with me and good luck. Okay. So that's today's date, blah, blah, blah. And here we go. Number patterns and relationships. Okay. Basically, you know that the yellow would be term 1. For this pattern specifically, term 1, term 2, term 3, and term 4. That is what the TE stands for. And N refers to any term. So you don't know where in this pattern N is. So N actually represents any and all pattern numbers in this specific pattern. Then they can ask you to determine term 50, term 100, term 88. It is a random term number that is far out in this pattern so that you won't be able to go and draw them. So basically, we're just going to look at how we're going to solve for Tn. Okay, the first step we do is we set up a table. So in this table, we want specific information. We need to have input and output. We need to have 4 columns for term 1, term 2, term 3, and term 4. Then they always ask you to do it for the next 1, 2 terms. You need to be able to do it for term N and then for term 50 or 100 or whatever. So that is the table we're going to draw for today. So the first thing we put in is our term and then the value of the term. So term 1 and 2 and 3 and 4, we have to determine 5, 6, N, and let's just say 100. Okay, what is the value of term 1? Term 1 has 2 dots. Term 2 has 4. Term 3 has 6. Term 4 has 8. So this would actually be your next step. Okay, place all the information you already have in the table. So we've put in the 2, the 4, the 6, and 8. That is what we have. The next step, complete the next 2 terms to confirm the pattern if you can. There's 10 and there's 12. Okay, so we are not sure how to determine N yet, and we can't do 100. So there's a few steps that we can do. The first thing we do is we determine a constant difference between the values if there is one. So we have a basic formula that we use specifically when we do patterns. You probably haven't used it yet, so I'm going to give it to you to help you for the future. So we use a formula called Tn is equal to An plus C. Okay, so in this formula, A represents the constant difference, and that is what we're going to determine there. Okay, so let's find out what A is. So we take the information we already have and we say 1 plus what will give me the value of the next term. Okay, hang on, we should have started at 2. So our first answer is 2. 2 plus what will give me our next answer, which is 4. So 2 plus 2. And then we go to 4. 4 plus 2 would give me our next answer, which is 6. If we continue this, we go to 6 plus 2 should give us 8. And 8 plus 2 should give us 10. So we can see that our constant additive, whatever we are adding here, is constantly a 2. Therefore, if we write it for A, would be A plus 2. Okay, no, A is 2. A is our constant difference, which is 2. Okay, step 5, you have to work out the formula using a specific pattern for the pattern, and this is the method that I like. It basically sums up all the information you have properly and gives you space to calculate. Okay, so the first term that we have, our answer was 2. The second one was 4. Then we had 6, 8, and 10. We determined the value of A there. So if we place it in the formula here, it becomes A, then our term number plus C. Do we know what C is yet? No, we have to determine C. So A would be 2. Our term number is 1. And 2 times 1 is 2. The next one, 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. So if we look at just that multiplying with A part, then we see that we already have the answer that we need. However, our formula, let's go back to it, says plus C as well. So if we still have to add a C here, what are we going to add to make this equation still true? We will have to add 0. So 2 times 1 plus 0 would give us our 2. Oh, 0, no, 2, there. So if we add 0 to 4, we still get 4. To 6, to 8, to 10, and to 12. So we add 0, therefore we don't need to write it. So our general formula would just be 2n. And if we apply it to the 100th term, we say 2 times 100 will give us our final answer, which is 200. Let's do the next one. Okay, step 1, place all the information in the table. The value of term 1 is 1, for term 2 is 3, 5, and 7. Let's see what we've done. We said 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 would therefore give us our term 5, which will be 9. And if we say 9 plus 2, it will give us term 6, which would be 11. Now let's fill that in here. That gives us 1, 3, 5, 7, 9, and 11. Our constant difference we have actually already done. We've done it here. That would be the value for A. So if we place A in our formula, which is 2, we multiply by our term number, which is 1. And we have to add C to get to 1. So let's see what we get. 2 times 1 is 2. We need to get to 1. So our answer has to be 1. What do we need to do to 2 to get to 1? We have to subtract 1. And let's do the next one. I'm just going to move it a little. Okay. So if we take that information and we apply it to the other ones, we can say 2 times 2 would give us 4. Alright? And 4 minus 1 is what we need to do to get to 3. Let's apply to the next one. 2 times 3 plus C. We can see that 2 times 3 is 6. We have to get to 5, therefore we also subtract 1, which will give us our 5. 2 times 4 plus, now if we use our common logic here, we can see that in each case so far, we have subtracted a 1. Let's apply that and subtract 1 there as well. And see if we get to the same answer that we need. Okay, so 2 times 4 is 8, and 8 minus 1 is 7, and that is actually what we want. 2 times 5, let's apply it again, minus 1 will give us 10 minus 1, and that would also give us our 9. The next one is 2 times 6 minus 1 is 11. Okay, so from this information, we can see that what did we do in each step? We subtracted a 1. So in our basic formula, which is AN plus C, we can say A was this 2, that is the constant difference that we determined between each term. So that was our constant difference, and that is the value that we want for A. In each other case, we subtracted a 1. So what did we add? We added a negative 1, which is fine. Okay, that is what I tried to explain earlier, that you can add or subtract a number here. So our general formula would be 2n minus 1. So let's apply it to 100. So 2 times 100 minus 1 will give us our 199. That would be the value of the 100th term. Let's do one other one. This one is not going to fit into our normal formula, and that is why I want to do it. You need to be able to recognize patterns. That is common knowledge as well, basic maths study work. So in this term, here we've got term 1, which is 1. Term 2 is 4, term 3 is 9, term 4 would be 16. Term 5, let's see what our constant difference is. 1 plus 3 is 4, 4 plus 5 is 9. 9 plus 7 is 16. So here we can see that there is a pattern, plus 9 and plus 11. However, this is not a constant. It changes. Therefore, our pattern still looks like this. However, there isn't a constant difference that we add. Therefore, we can't use the formula AN plus C. We have to come up with something else. So if you look at what our answers should be, look at the pattern itself. We've got 1, we've got 4, 9, and 16, and those numbers are very special numbers, as you know. They are all called squared numbers. Therefore, 5 times 5, which would be the square of 5, is 25, and the square of 6 would be 36. So in our table, what did we do? We said 1 times 1, and 2 times 2, and 3 times 3, 4 times 4, 5 times 5, 6 times 6. So therefore, we have to say n times n, and 100 times 100. And that is our answer for this pattern. It would be 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36. This would be n squared. I just want to put a 2 in there. Oh, no, that's not going to work. N squared. Hang on, I actually think I can type this. Let's put a 2 there. So this is n squared. There's a square. And that would give us our 10,000, which is the value of the 10th term. So this basically is the one that you need to study and know out of the top of your head. The rest of them are all self-explanatory if you follow the pattern. And that is today's lesson on number patterns. Please let me know if you are stuck somewhere or if you need some other help. Have a lovely day further. Bye bye.